Hello, welcome back. Today we're going to talk about FSDP2. As a refresher, what is FSDP? FSDP is a way to scale models across multiple GPUs. In particular, what FSDP does is it shards the parameters of a model across multiple GPUs. And then during the forward pass, when you need the parameters for a layer, you unshard, or you all gather the parameters by sharing the various shards to each other GPU. You do your computation, and then you quote-unquote reshard, where you just drop all of the data that doesn't belong to your GPU. And with this, it allows you to scale model sizes up because you're not storing the full model on a single GPU. And so historically, we've talked about compiler-oriented ways to do this, namely simple FSDP. But today we're going to talk about FSDP2, which is an eager framework FSDP implementation. What does it mean to be an eager framework FSDP solution? It means that we actually do not have a view of the entire graph. In particular, really FSDP just is implemented locally via hooks. So the way that FSDP2 is implemented is each NN module in PyTorch has what's called a forward prehook and a forward hook, which represents a forward posthook. And the forward prehook will always run before the forward function, and the forward posthook will always run after the forward function. And the way FSDP2 works is in the forward prehook, it does the all gather, or it does the quote-unquote unshard. And in the forward posthook, it does the reshard. And then, as we'll see shortly, there's also some work to set up the backwards to make sure that backwards we can do the shard and unsharding appropriately. So here we have some code, and you can see that we've just run an example with two GPUs where we're doing Llama 3 8B, and we're enabling compile. So if we look at the stack trace, we can see that the magic happens here, where right now we have a basic model where, if you scroll up, you'll see that it's a basic transformer with an embedding layer, a bunch of transformer layers, and then a RMS norm, and then a linear layer. And here we can see that we apply parallelism. And so, as an aside, I think this is interesting to see. So the first thing we do is we apply activation checkpointing. And so after we apply activation checkpointing, if you look at the model again, you'll notice that these layers, which previously were just transformer blocks, are now wrapped in a checkpoint wrapper. And this checkpoint wrapper will handle the activation checkpointing. And if we run here, after we apply the compile, and we look at the model again, we can see that we've further wrapped it. So now the checkpoint wrapper is now wrapped with an optimized module, and this is what torch.compile does. And then lastly, we will apply FSDP. So this is where we'll look at the code. So what does apply FSDP to do? It basically calls this fully shard method on the token embeddings, the transformer block, the norm, and then the full model. And what is this fully shard and where it's defined? Fully shard is actually defined in Torch. So it's defined in Torch distributed FSDP. So let's take a look at the fully shard method. So if you look at the fully shard method, it has a great doc block. But here you can see it uses the registered forward prehook and registered forward posthook to do the all gathers and the reduce scatters for the gradients. And if we look at the implementation, the magic happens here, where we get the state for a particular module, and then we call this state.init function. And what is the state? This state is an FSDP state. And so if we look at this def.init, we can see that indeed here's where the magic happens, where we register a forward prehook and we register a forward posthook. Now, before we dive into the code, I want you to think at a high level about like the high level goals we're trying to accomplish, right? So what we're trying to accomplish is in the pre-hook, we're trying to do an unshard or an all gather. And in the post-hook, we're trying to do a reshard. And then similarly in the backwards, we want to do an unshard when we compute the backwards, and then we want to do a reshard once we're done computing backwards. So if we go back at the code, we can see that in the register forward prehook, this self.preforward, we do a few things. So the first thing we do is for the parameters we call the preforward method, and as you can see here, we indeed do the unshard. So this corresponds with this, right? So like when the preforward hook runs, it will unshard, which is kind of what we want. And then critically, it will also call this register post backward hook. And what this does is it calls this register post backward function, which is a autograd function. And you'll notice that in the backwards, it calls this ctx.paramgroup.postbackwards. And if you look at this post backward function, you'll see that it does a reshard. And this corresponds here, where we want to register the post backward hook so that after the backwards we reshard. So so you can see so far we've basically managed to do this and this. So now let's go back and let's look at post forward. So in post forward, we call register, we do a few things. So first of all, we call FSDP2 and what this does is a reshard. So as you can see, it's doing exactly what we want, right? It reshards after you've done the forward computation. And then afterwards, it calls this register pre-backward hook. And what this does is for each tensor that requires gradient, it registers a hook onto that tensor, and it registers its pre-backward function as the hook. And here, it will call FSDP paramgroup.prebackwards, and here you can see the unshard, which represents this, where you will unshard so that you can do the computation for the backwards. And yeah, we have basically all four of these covered. And so as you can see, FSDP2 is quite complicated because of all these callbacks and hooks, but hopefully at a high level, you kind of see the structure and how everything works. The last thing I want to point out is how we make this efficient. And I'm not going to go into too much of the code, but I do want to point out some of the code. So the key behind making FSDP efficient is this idea of prefetching. So you'll see in a lot of the hooks, in addition to doing this pre-backward stuff, we'll do this prefetch unshard. And this, in general, this like prefetch step is useful both in the forwards and the backwards to ensure that we start a prefetch. We start a prefetch for the next layer as we're doing the current layer. So in practice, what this means is if we're doing layer 1, we can actually prefetch layer 2, such that once we're done with the layer 1 computation, the layer 2 communication is done. And so if we can nicely overlap the compute and the communication, in practice, we actually don't have too much what's called exposed communication, and that's what gives us the efficiency. Okay, so hopefully this was helpful. Maybe in a future video we can dive more deeply into a particular segment, but hopefully this gives you a high-level overview of how FSDP2, the eager framework works, and I'll see you in the next one.